Okay, ladies and gentlemen, we are going to look at another idea here. This idea is the idea of a rational indice, or a rational index. I shouldn't say rational indice. That doesn't make any sense. A rational index is one where we have a fraction as our index. The reason why is the word rational in mathematics means can be divided. So it's a division problem. Fractions are division problems. That's where that comes from. So these are the rules. A to the 1/2 power equals the square root of a. And a to the 1/3 power is the square root of, or the cube root of a. And a to the 1/n is the nth root of a. Those are the rules. You can get those from the textbook. What I want to show you is why. Why does this happen? So I want to actually prove that first rule, because I think if we prove the first rule, the rest makes a whole heck of a lot more sense. So I'm going to do that. What we have said is that if I want to know what a to the first power is, and I want to be able to write these as indices, well, I could rewrite this as a square root of a times the square root of a. Because if I multiply square roots together and it's the same thing, then it just becomes that other square root. So just some proof of that, I've already done it here. The square root of 5 times the square root of 5 is in fact 5. Yeah, that makes sense. We can make that work. So if I wanted to, I could rewrite this as an index. Now we already know what the index is going to be, but let's say that we don't know what that index is. And let's just rewrite this as a to the nth times a to the nth. And I'm saying that this is still going to be equal to a to the first power. Now, looking at this left-hand side of my equation, that's an index law. Specifically, that index law is I multiply two indices that have the same base together. I just add the indices together. So that would turn into a to the n plus n, and the right-hand side hasn't changed at all. Now I'm going to simplify that one more. If I've got n plus n, my rules of combining like terms allow me to rewrite that as a to the 2n is the exact same thing as a to the 1. Well, if those two sides are the same, and that's what our equation's saying, then the bases are the same. That means that the indices have to be the same as well, right? That means that this 2n has got to be the exact same thing as 1. So just continuing on with our algebra foo, that ancient martial art that we're all so fond of, I get 2n has to be 1, because if they're equal, therefore my indices have to be equal. Solving that tells me that n has to be 1/2. Bringing that back to where we started, what this turns into is a to the 1/2 is the exact same thing as the square root of a. And that's why this rule exists. That's why that rule is there. And again, we could do that with other values. You could do that with a to the 1/3, because if we did the cube root of a times the cube root of a times the cube root of a, we would get a to the first, and then we would be able to do that same process to find that. That's awesome. That is a great thing that we can do. Now we can operate with rational indices. Let's do that. Let's just look at a quick one. I don't know, let's do 5 to the 3/2 power. 5 to the 3/2 power. Now we're doing something different. So we're going to break this apart just like we did with the negative indices, where the first thing we're going to do is let's get rid of the numerator of this thing. So if I got rid of this numerator, I would end up with, like, I could break this apart into 5 cubed, and then that 5 cubed to the 1/2 power. Checking that, 3 times 1/2 is 3/2. Okay, I'm back to where I started from, no big deal. So now I've got it 5 cubed raised to the 1/2 power. Well, I just need to rewrite that as the square root of 5 cubed. Bam, we got it, we're good. I'm really happy with that. I'm just going to do a check with my calculator just because, who knows, Stoltz makes mistakes. So let's try that. I want to do the square root, control square root of 5 to the 3rd power. When I do that, actually, I'm not going to show you what that answer is. I'm just going to do the next part. I'm going to do 5 to the 3/2 power. And now the big reveal, once I move this over, ta-da! Thank you. I can hear you in the background. Yes, excellent. Anyway, with that, again, I think you're just dangerous enough to get stuck into some problems and to do this work. So hope that's helpful. Good luck, everyone. I will see you in the future.